Hello again, friends, and welcome back to 2012 BC Calculus free response questions. This is number 4. I didn't have space in the last video because I talked too much. So it may end up that I just do one question per video. They do give you 15 minutes, on the AP exam for each free response question. And so I guess it would make sense that me talking through the whole thing would take 15 minutes to do that first question. The thing about this question is we only know how to do 2 parts, so this video shouldn't take as long, right? You have a table on question 4, where in the table, notice they're giving you f prime, not f values, right? So we have x and we have f prime of x. Part A, equation of a tangent line, OMG. To do the equation of a tangent line, I would hope that's like a gimme by now, right? You need 2 things. What are the 2 things? Let me hear you. Come on, louder. So your parents can hear you. Yeah, that's right. Point and a slope. Point and a slope. And so in these words up here, they tell you twice differentiable function with f of 1 equals 15. So that's super duper important for part A. You have to use this for part A. The twice differentiable function is important because I'm going to need a couple derivatives for part D, which we don't need to worry about yet. This is a prime prime right here. It's actually kind of hard to, there it is, see, prime prime. So we won't need that for till part D as well. But for part A, you need a point and a slope. And to find the equation of the tangent line, you have y minus the y coordinate equals the slope times x minus the x coordinate. Oui? And so you're given the point 115. The slope at 1 is 8, and that comes from the table up here. The slope at 1 is 8. See, 115 is the point. F prime of 1 is 8. So you have the equation y minus 15 equals 8 times x minus 1, and you can distribute the 8 and add the 15 over, and that gives you 8x plus 7. AP exam, they usually will just leave this like as 8 times x minus 1 plus 15. Because if you distribute the 8 and do it wrong, then you lose points. So you don't have to put it in y equals mx plus b form, but you do probably want it to say y equals. So you want to move the 15 over. That makes sense, so that it's explicit in terms of the equation of the line. So this tangent line will approximate. So this is something we haven't really explicitly done a lot of, tangent line approximation or linear approximation. But basically we have, in that we found the equation of a tangent line before, like a bunch. And so the whole point of a tangent line is it touches the curve at a point of tangency. So that point they have in common, right? So the function contains the point 115 and the line contains the point 115. They touch at that point. So if you pick a number really close to 1, like 1.1 or 1.4 in this case, 1.4 is very close to 1. So the tangent line and the function resemble pretty much the same value, really, really close to the point of tangency. So we have talked about that before. And so they want you to use the tangent line to approximate the curve. See, we don't have the curve. We don't have f of x. We have a bunch of derivatives from the table. So I plug in 1.4 into the tangent line, and using the green equation, it's almost easier because 1.4 minus 1 is 0.4, and 0.4 times 8, right, is 3.2, and 15 plus 3.2 is 18.2. So you get to that same answer either way. That's part A. Part B, another way to approximate the function's value. So because we have a table of derivatives, right, we can use this table to calculate area under the curve. So they do ask you sort of 2 parts here, just like part A. There was what's the equation of the tangent line, and then use it to evaluate f of 1.4. So the same thing here is they're going to ask you to find the Riemann sum, and then use that Riemann sum to approximate f of 1.4 again. And that's a little bit trickery. Something that you might not have known how to do on your own, but when you see it, you're like, okay, that's pretty simple. I get it. But the first part, the Riemann sum part, should be pretty straightforward. Auto saving. The Riemann sum is where you use rectangles. Okay. Notice there's no sigmas written in here. You're not having to write the sigma of f of x sub I times delta x as I goes from 1 to n or any of that crap. It's two subintervals, two. So you're going to take this table, you're going to make two rectangles out of it. So you see right here, rectangle 1, rectangle 2. It tells you that you want the subintervals to have equal length. So the first thing you got to think about is from 1 over to 1.4 is how wide. That interval is a space of 0.4. So 0.4 cut in half means you want each rectangle to have a width of 0.2. Okay, and so from 1, we're going to go over to 1.2. And 1 to 1.2 is this part in this parentheses here, right? That is just 0.2. So I don't need to write the 1.2 minus 1. I just kind of did that to show you that's my first interval, right? Sub-interval, I guess. And then from 1.2 to 1.4, the next sub-interval also has a width of 0.2. So these are the widths, right? Remember, it's width times length. And the lengths are the height of the rectangles. The height of the rectangles, they ask you to use a midpoint sum. So midpoint means you want the x-coordinate in the middle of your interval to touch the function. So in the middle of the interval from 1 to 1.2 is 1.1. Isn't that great? And they happen to give you 1.1 in the table. So 1.1's value is 10. 1.3's value is 13. So those are the heights of the two rectangles, or the lengths of the rectangles. So width times length, or base times height, is 0.2 times 10, which is 2. And 0.2 times 13, which is 2.6. And these are, again, this question was no calculator. So, yeah, it's tricky to have to do those math numbers without calculators. Unfair, right? So 4.6 happens to represent the integral from 1 to 1.4 of f prime of x dx, right? The integral they ask you to find. And that right there is worth 2 points maybe, or 1 point on its own. You can at least get that point, all this red stuff, calculating using the numbers from the table. Now the second part, it wants you to estimate f of 1.4 again. So again, think about what we're doing is we don't have function f. We have a table of its slopes, right? This table represents all the slopes of f at certain x values. And so from our fundamental theorem of calculus, right? You down with FTC? Yeah, you know me. Remember the fundamental theorem of calculus says from a to b, when you integrate little f of x dx, that equals big F of b minus big F of a. Big F, little f, big F, little f, big F, whatever. So from the red to the blue here, the integral of f prime. What happens when you integrate f prime? What is the integral of f prime? It's f. So when you integrate from 1 to 1.4, f prime, you get f of 1.4 minus f of 1, and that equals the area under the curve, the area that we just found, right? It equals the definite integral from 1 to 1.4. So they ask you to approximate f of 1.4 as you have an equation for it here. So this part's, it's not difficult, but we haven't really maybe made that connection that I can use the fundamental theorem of calculus to solve an equation, right? If I know the area under the curve and I know the starting point, which well, it's way up there. Chopped it off. The f of 1, remember, was 15. F of little f, Martin. F of 1 was 15 from the very beginning. So you can now take the equation and add the f of 1 to the other side, right? So it's 4.6 plus 15. And 4.6 plus 15 makes 19.6. So with that, you've approximated the function's value at 1.4. And you notice 19.6 is pretty close to this 18.2 that's up here. Pretty close. So we're approximating the function's value. It's almost like we're, trying to predict trying to predict information without having, all of it to begin with. So we don't have function f, but we can try our best to determine values of function f using a tangent line, using a table to get the area. Now, part C is Euler's method, and part D is a Taylor polynomial. Both of those are going to do the same thing. So you look at part C and part D, which are not even on here. I cut them off. You're going to see two other ways to approximate the function. What I did save at the end of this file, and I can post this PDF as well as these videos, are the guidelines for the scoring rubric. So this was question 3 that we already did in the other video. You see it's 2, 2, 3, 2 for A, B, C, and D. And then the two questions that we just went over from question 4, right? You got 2 points for part A. The tangent line was 1 point, and then approximating f of 1.4 using the tangent line was also 1 point. The Riemann sum was 1 point, so that's just getting this, sum here. And then notice you get a point for recognizing you need the fundamental theorem of calculus. They wrote it kind of backwards here. You could write it the way I did up there with the integral equals f of 1.4 minus f of 1, and then you just add the 1 over to solve, which is the last point is the answer. So 2 and 3 were worth 5 points. When we see part C and part D, then you'll see each one of those, I think, was 2 points each. I'm going to basically keep creating videos, and then I can upload videos. I think next video we might do is might as well just continue with this problem and do part C. Part C is Euler's method. So look for another video on Euler's method soon, and we can practice that. And I also want to say have a good spring break. I'm doing this right now here at the end of our snow day vacation, getting ready to start spring break. We'll see over spring break. I might post some videos. You technically don't have to look at them, but whatever. We'll see what's up. Anyway, take care. Peace.